guys, welcome back. We are going to consider chemistry practical under neutralization titration reaction today. And the question before us is to determine the concentration of ethanoic acid in sample of the vinegar. 50 centimeter cube of the vinegar were diluted to 500 centimeter cube. And then the diluted vinegar was titrated with a previously standardized solution which contained 2.4 grams of sodium hydroxide in 500 centimeter cube solution. Now this is how they prepare the reagent that was used for the neutralization reactions, because it involved ethanoic acid and sodium hydroxide. So it's a neutralization reaction between acid, base, and salt. Acid and base to give us salt and water. So that's what we call neutralization reaction. So now we are told that this ethanoic acid was inside vinegar. That's where our acid is. Our acid is inside the vinegar, which is known as ethanoic acid, and we have to determine the concentration of that ethanoic acid in that vinegar. But to carry out this experiment, 50 centimeter cube of vinegar was measured, and then what apparatus is best suitable to measure 50 centimeter cube of what vinegar is? Let's consider the measuring cylinder. The measuring cylinder is the appropriate apparatus when you are carrying out this in a lab. So this is a measuring cylinder, and it's 50 centimeter cube. So this one should be around 50 centimeter cube. So our vinegar was actually diluted. So it was diluted, and to dilute it, we use 500 centimeter cube of what? Deionized water, which means that we are going to use what? 500 centimeter cube of what? Of volumetric flux. So a 500 centimeter cube of volumetric flux was also used. So this vinegar was transferred into 500 centimeter cube volumetric flux, and then it was marked up to 500 centimeter cube. So we have our vinegar being diluted here. So we have a diluted 500 centimeter cube vinegar. Now what is very, very important here is that you need to know the diluent factor. The diluent factor is just 500 divided by 50, which is 10 times. Meaning that what? The concentration of vinegar that we now have now is 10 times lesser than the concentration that we have before. So that's what we call diluent factor of 10, because 50 divided by 500 divided by 50 is what we know as 10. So the diluent factor is the diluent factor is 10. So take note of that. So now we are told that this was now being titrated with a standardized solution of 2.4 grams of sodium hydroxide in 500 centimeter cube of our solution. Now this also was produced by weighing 500 grams by weighing 2.4 grams of sodium hydroxide. So you can see, you can use petri dish, and then you weigh about 2.4 grams, and then they put it in a beaker and added some drop of water with a stirrer to stir they add water, they add water, and then they add this also into it to actually mix it up and dissolve sodium hydroxide. The sodium hydroxide is now transferred into another volumetric flux of 500 centimeter cube. This volumetric flux, another volumetric flux separately 500 centimeter cube volumetric flux. So now, and then it was also marked up. So this was transferred to this place, and then it was marked up with water as well. So 500 centimeter cube of sodium hydroxide solution, and then we also have this is of vinegar now. So that's that about the preparation of the reagents used. Now these are the most important things. On average, 20.50 centimeter cube of the diluted vinegar were required to neutralize 25.0 centimeter cube of this sodium. Now it required 20.50 centimeter cube of the diluted vinegar to neutralize 25.0 centimeter cube of this solution of sodium hydroxide solution. Now what it means is that it takes about the volume of vinegar required to neutralize the 25 centimeter cube of sodium solution is what? 20.50 centimeter cube. That is the volume of vinegar that is required to neutralize 25 centimeter cube of what? Of the sodium hydroxide solution. So sodium hydroxide, the volume of sodium hydroxide solution that was used is 25.0 centimeter cube solution. So it means that they pipette 25 centimeter cube of what? Of sodium hydroxide into a conical flask. Into what? Into a conical flask. What do I mean by this? They pipette this into a 25 centimeter cube of the sodium hydroxide, which is the what? Base, into the what? Conical flask. Let me just draw this conical flask, just a sketch. The conical flask is not as what? It doesn't have long neck as this, so this is conical flask. So they put sodium hydroxide inside this, and then they put it under the burette, just like we have it in the previous experiment. So they put under the burette. So this is our retor stand. So now the vinegar was here, and then 25 centimeter cube of what? Of sodium hydroxide was here. So we are now told that after they carry out series of experiments, they titrate this with this. They said about 20 centimeter cube, about 20.50 centimeter cube of vinegar was able to neutralize 25 centimeter cube of sodium hydroxide. That's what they are trying to say here. That's what they are saying. So the volume of vinegar neutralized 25 centimeter cube of what? Of sodium hydroxide. So that's what they are trying to say now. So that's that about that. So I will quickly clean this now so that we can move forward and have space to solve these questions. So now, with this now, we are now asked to what? To calculate the number of moles of sodium hydroxide in each 25.0 centimeter cube portions. Now, how many moles of sodium hydroxide is in each 25.0 centimeter cube of portion of that what? Of that sodium hydroxide. Now, for every 25 centimeter cube of what? Of sodium hydroxide, how many moles of sodium hydroxide is present in it? So that's what they mean. So what we are going to do is that, okay, we are looking for a number of moles of sodium hydroxide in 25 centimeter cube of sodium hydroxide that is being pipetted into conical flask. So how to go about this is, you are going to write it out first. What I'm looking for is that I'm looking for number of what? Moles. Number of moles of sodium hydroxide in 25 centimeter cube of solution. That's what they are trying to ask us. So how do you get number of moles? The first thing is that you need concentration in mole per dm cube, which is known as concentration in mole per liter, whichever the case you wanted to know. So the first thing is to calculate the concentration of sodium hydroxide now, which is mole over what? Volume. Mole over volume. Please take note of that. Concentration of sodium hydroxide in mole per dm cube will be mole over volume. Now, how do we get mole? That's the first question. Mole is gotten from mass of sodium hydroxide over what? Molar mass. Molar mass of sodium hydroxide. Molar mass of sodium hydroxide. Mass of what? Sodium hydroxide over molar mass of what? Sodium hydroxide. So what does that mean? It means that the mass here is going to be what? 2.4 grams. That's what the mass of that was weighed. Don't forget, 4 grams was weighed all over the molar mass of sodium hydroxide. What's molar mass of sodium hydroxide? So that it means that you are going to add the atomic mass of sodium plus the oxygen plus the what? So 23 plus 16 plus 1. So if you add them together, this will be 2.40 grams divided by 40. So this should give you what? In terms of mole now, it's going to give you what? 0.06 mole. Yeah, I think it should be. So this calculator. So now, having gotten this now, what is the next thing? Don't forget, we are looking for number of moles of sodium hydroxide in 25 centimeter cube. Now, the first thing, and we are trying to calculate the concentration of sodium hydroxide. So the concentration of sodium hydroxide now will now be what? mole over what? Volume. Mole over volume, which is 0.06 divided by the volume. Don't forget the volume here that was given, that was used to dilute the solution of 2.4 was about what? 500 centimeter cube. 500 centimeter cube. So you need to take that 500 centimeter cube to what? To dm cube. So you divide this by 1000. You divide this by 1000. So when you divide it by 1000, you get is 0.5. So I won't do that. I will just write 0.5 dm cube. So you are expected to do that. So 0.5 dm cube. So when you divide this one, what do you get? Divide this one, what do you get? So if I divide this one, 0.06 divided by 0.5, I'm going to get 0.12 mole per dm cube. Is 0.12 mole per dm cube. 0.12 mole per dm cube. So I haven't done this now. I can now say, okay, I've done this one now. So what I'm going to do is that I'm going to clean this. So to now get number of moles in 25 centimeter cube, it's very simple. Number of moles in 25 centimeter cube, using concentration again, you know, we know that concentration is equal to mole over volume. So if concentration is mole over volume, then by making moles over formula, we have mole is equal to concentration times volume. As simple as that. So mole of sodium hydroxide now in each 25 centimeter cube that was pipetted will now be what? What's the concentration that you get? Is 0.12 times, what's the volume? 25 centimeter cube. So 25 divided by what? 100. So whatever you get will now be your answer. So what's going to be our answer? Let's check. So let's check that. Calculator. Zero 0.12 times 25 divided by 1000, not 100, 1000. It's going to give you what? It's 0.03 mole per mole. So it's mole that we are talking about now. So that's that about that one. As simple as that. So now the next question was now is what? Not what is the number of moles of ethanoic acid per centimeter cube. What is the number of what? Mole of what? Of ethanoic acid per centimeter cube. What is this now? How do you get this number of moles of what? The first thing is 4 of us. I told you before you can get moles, you must 4 of us get what? The concentration in mole per dm cube. So the first thing is the 4 of us. We are looking for number of moles of ethanoic acid. That was the question anyway. Of ethanoic acid, which is COH. Now, but number of moles, look at this, number of moles of ethanoic acid per centimeter cube, per cm cube. Take note of that. Per cm cube. So what does that mean? Is that what you are going to do is that you are going to recall for this formula. There's a formula we don't usually use for this. We have MA of VA over MB, VB equal to NA over N. This is a very fast formula to use. So that's what I'm going to use now. And what we're going to do is that we are going to say, okay, what's the molar concentration of A? What's the molar concentration of B? The molar concentration of A here is what we are looking for, which is the acid. And then the volume has been given, which is 20 point what? That's the average volume. All over, what's your molar concentration of B? The molar concentration of B is what we calculate as 0.12. 0.12 times what? Times 25, you can see, 25. You don't convert, that's why they say per centimeter cube, you don't convert it. So now, per centimeter cube, so 0.25, 0. So all over, what's the mole ratio of acid to base? This is 1, this is 1. So it was 1 mole of ethanoic acid and was reacted to 1 mole of sodium hydroxide. So we have 1 over 1. So by cross multiplication, we are going to have MA to be what? To be 0.12 times 25 divided by 20.50. If you do your calculation very well, So we cross multiply and then we divide both sides by 20.50. So what do we have? So we have 0.12 times 25 divided by 20.50. So we have, look at this, the 0 point. So we have MA now is equal to 0.146 mole per dm cube. This is the mole per dm. Find the concentration of ethanoic acid in the original was vinegar. Now the concentration of the original acid is this 0.146 of the diluted. You just have to multiply this in the original acid. For the original acid, you just have to say 0.14 centimeter cube mole per dm cube. Now this is the one that is diluted, but multiplied by the diluted factor, you will get the original one. So which is going to be what? It's going to be 1.46 mole per dm cube. That's what it's going to be. To get the original one, you multiply by the diluent factor. So the original value of the concentration of vinegar will be what? The concentration that you get multiplied by the diluent factor, which is 0.146 times 10, which is the diluent factor. That's why you get this. Your approximately this is going to be what? Approximately 1.5 mole per dm cube anyway, which you are not told to do. So 0.14. So to now calculate this in percentage now, said calculate now in terms of, they said we should calculate this original in terms of what? Mole per liter, which is 1.5 mole per dm cube. Mole per, this is already in mole per liter. Now the next thing is to calculate it in what? In weight per volume. Weight per volume. Now what does that mean? What do we mean by weight per volume? That is percentage weight per volume. That is the weight must with volume. Meaning that the first thing you need to do is that you must actually convert this to mass concentration first before you can even say percentage per volume. Convert this to mass concentration first. So what you are going to do is mass concentration is equal to molar conc times molar mass. Molar conc times molar mass, which is equal to, what is molar conc? Is 0.146. This is molar conc here, the original one. Okay, this one. Let's use this, yeah, this one, because we are using this original 1.6 times molar mass of what? Of ethanoic acid. Don't forget this is ethanoic acid. So 1.46 times molar mass of ethanoic acid. Now let's ethanoic acid is CH3COOH. How many C? 1, 2. So 2, 6. That is 2 times 12. How many hydrogen? 1, 2, 3, 4. So that is what? 4 hydrogen plus 4 into brackets 1 plus how many oxygen? 2 in brackets 16. So we are going to consider that one together. So it's going to be what? 24 plus 4 plus 32. So just make things easier for us once and for all. We are going to, so we are having 1.46 so we're having we're having what? Let me try another one, another calculator. So 1.46 multiplied by 24 plus 4 is going to give what? 28. 28 plus this one should give us what? Should give us 60 times 60. So 8, this is what? 80 what? 87.6 gram per dm cube. That is the mass concentration. So 1.46 times 28 plus 32 is what? Is 60 times 1.46 is got is giving us what? 87 point what? 87.6 gram per DMP. That is what this one means is this. What it meant is that 87.6 gram was dissolved in 1000 cm cube. That's what it means. Because it is DMK means 1000 cm cube. So 87.6 gram was found in 1000 cm cube. But in weight per volume, percentage weight per volume now, percentage weight per volume, it means that the weight must be in 100 cm cube, not in 1000. So in order to convert it to percentage weight per volume, your volume must be in 100. So we are going to be what? 100 cm cube now. So assuming 100 cm cube, what will now be my what value here? So we make it x. Are you getting it? So when you cross multiply, this is going to be 1000x equal to 87.6 times 100. So divide both sides by what? 1000. So this is just going to be what? This one cancel this one. This one is going to go back by what? Because divided by 10 is going to be what? 8.76 percentage weight over volume. So that's what I mean. So 8.76 percentage weight per volume. That's the answer.